ICSE 10th Chemistry Metallurgy chapter quick revision we are going to do in this video. So understand the definition of minerals. Minerals are the naturally occurring compound of metals and they are mixed with other substances. Whereas ore is a mineral from which metal can be extracted commercially. That's why all the ores are minerals, but all the minerals are not ores. And in the ore you can find some impurities. Those impurities are called as gangue or matrix. So in the syllabus we need to discuss or remember the common ores of aluminium, iron and zinc. The common ores of aluminium are bauxite. This is the main chief ore of aluminium. Formula is Al2O3 2H2O and chemical name is hydrated aluminium oxide. The second ore of aluminium is cryolite. Formula Na3Al(F6) and chemical name is sodium aluminium fluoride. Students, remember the common ores of iron also. The main ore of iron is red hematite and brown hematite. Red hematite Fe2O3 anhydrous ferric oxide, whereas brown hematite is Fe2O3.H2O, that is hydrated ferric oxide. The common ores of zinc are zinc blende and calamine. Zinc blende ZnS, zinc sulfide, and calamine ZnCO3, zinc carbonate. And you need to remember the definition of metallurgy. Metallurgy is a process of extraction of metal from their ores. And during the metallurgy process, the first step is dressing or concentration of ore, and in this step there is a removal of impurities from the ore, removal of gangue from the ore. Now there are four dressing methods of ore are there. The first one is hydraulic washing, and the principle of this method is difference in the densities of ore and gangue, and this method is suitable for the ore of iron and tin. Second is magnetic separation. It is based on the magnetic property of the ore. And third one is very important, froth flotation process, and the principle is preferential wettability of ore with oil and gangue by water. And froth flotation process is suitable for sulfide ores like zinc blende ZnS. Then leaching method of dressing is where the ore is soluble in particular solvent. For example, bauxite ore is soluble in sodium hydroxide caustic soda. So next important method of metallurgy is conversion of metal ore into oxide form. So it has two steps, roasting and calcination. In roasting there is a heating of ore in the presence of excess of air, and roasting is suitable for sulfide ore. When they heated in the presence of air, it converts to its oxide form by the release of sulfur dioxide gas. In calcination, ore is heated in the absence of air. It is preferable for carbonate ores like calamine. When you heat, it converts to zinc oxide with the release of carbon dioxide gas. So next important one, you need to remember that zinc oxide ZnO is reduced to zinc only by heating with carbon, that is coke. So when you heat zinc oxide with coke or carbon, it reduces to zinc. So here coke is a strong reducing agent. Then remember, aluminium is a powerful reducing agent. That's why it is used in aluminothermy. In aluminothermy, aluminium powder and iron oxide are ignited, where the iron is melted and can able to join the two broken iron pieces, that is called as aluminothermy. Now come to the most important part of this chapter, extraction of aluminium. And aluminium is the most abundant metal on the earth crust, and it is extracted by a main ore called bauxite. So in the first step of extraction of aluminium, we need to do Bayer's process. It is one of the leaching method to purify bauxite ore by removing gangue or impurities. So here in Bayer's process, we are going to convert bauxite ore into alumina. Bauxite ore into alumina. This conversion we are going to do in Bayer's process. So in Bayer's process, we use one solvent called caustic soda. In this solvent, bauxite ore is soluble, whereas impurities are not soluble. They are formed red mud, that is removed by filtration. So it has three steps. In first step, bauxite ore is heated with caustic soda at 150 degrees Celsius, where bauxite ore is soluble in NaOH to form sodium meta-aluminate along with the formation of water, and impurities are insoluble, they form red mud. Now in the second step, this sodium meta-aluminate we takes to the second step where we are going to add water to reduce the temperature to 50 degrees Celsius, where this sodium aluminate is converted to a precipitate of aluminium hydroxide along with the formation of NaOH. This NaOH can be reused for another Bayer's process. Now in the third step, whatever the aluminium hydroxide we got, that we need to heat at 1000 degrees Celsius where it converts to alumina along with the formation of water. So like this, in Bayer's process, we convert bauxite ore into alumina by removing the impurities in the Bayer's process. Now next step in extraction of aluminium is extraction of aluminium from alumina. In Bayer's process, whatever the alumina we got, from this alumina we need to extract aluminium, and the best method is Heroult process or electrolytic reduction of alumina. So in Heroult process, we need to use one electrolytic cell where graphite carbon can be used as positive electrode called anode, and in this stainless steel tank the inner lining should be done with carbon and it is act as negative electrode called cathode. So at the bottom there is one hole from which molten aluminium can be removed after the process. Then in this tank we need to use electrolyte, that is 20% alumina, 60% cryolite and 20% fluorspar, and we need to sprinkle the coke. So during this process we need to heat, and that time whatever the aluminium present in alumina and cryolite, it converts it into aluminium ion Al3+. So that gains electron. Gain of electron is called as reduction. So at cathode, reduction takes place and converts into molten alumina that is removed from this tap. Then in the at anode the reaction occurs is loss of electron, that is oxidation. So whatever the oxide ion O2- will be there, it will lose electron to form oxygen. That oxygen combines with carbon lining of anode, carbon of anode, and convert into carbon dioxide. That's why as the anodes, which is made up of carbon graphite, is oxidized into carbon dioxide, we need to replace anode from time to time as it gets oxidized. Remember for exam, very important. Now in electrolytic reduction of alumina in Heroult process, the role of cryolite is used to reduce the fusion temperature from 2050 to 950 degrees Celsius, and it will increase the conductivity of the mixture also. And we are adding 20% fluorspar, it acts as a solvent as well as it increase the conductivity, and we will sprinkle coke on the tank that will reduce the heat loss and prevent the burning of anode. So these are the importance of this electrolytic mixture. At the end of this chapter, we remember about alloys, especially stainless steel composition, it's used duralumin composition, it's used brass composition, bronze composition, and fused metal solder composition. So notes I am going to provide in the description. It's PDF that you can download, and I hope this video is going to be very helpful for the coming exams. Thank you, students.